For part 2 of module 2, we're going to look at output, and more specifically maximum deflection and deflection limits, and how can you use Carumba to help you figure those things out. And a quick way to understand it, Wikipedia article explains it pretty well, but deflection is the degree at which a element is displaced under a load. And generally, building codes will determine those maximum deflections, and it's usually a fraction of a span. So when you have something like a beam with a load being applied to it, you would take the length divided by a certain number told by code, usually things like 240 or 360, and that will be the maximum that this deflection dm could be. The maximum deflection has to be below L over, say, 360. So in Carumba, going back to the definition that we used, Carumba very helpfully tells you the maximum displacement, but it does not tell you which beam is displacing that much. So that's for you to figure out. So if you go to the analyze command and pull out a notepad like I just did, or a panel, and then draw from the displacement to there, it tells you one displacement. And this is the most one element is displacing. So to figure out which element that is, there is a command in Carumba under Utilities, or sorry, Results, Beam Displacements. And you draw from model to model, and then pull out a panel again with a double slash, and then from translation, because that will tell you the translations of each beam. And this is telling you how much each, the start point and the end point of each beam is, but you can see that there's 13 beams from 0 to 12. And if you go, pull this down, the maximum deflection matches the deflection of beam 2. And so if we want to figure out how long beam 2 is so that we can get that ratio of L over 360, we can go back to the curve command up in where we set up the baselines and go to the curve panel, analysis, length, and pull from the curves into the curve panel, and then double click for the panel and go from length to that. And you can see that there's 13 members, 0 to 12, which means it corresponds to the 0 to 12 members listed here. And beam 2 has a length of 25.658447. So you can open up a calculator, do 25.85 divided by, say, 360, 0.0718. That is the maximum deflection allowed by code. And clearly, we are beyond that displacement. And also, you can look, if you hover over the displacement output, you'll see a unit. So this is 0.5 meters displacement, and that's how much one beam is displacing. And clearly it's outside of code regulation if code was maximum displacement equals L over 360 or something like that. So that's a very simple way to see if whatever you're designing fits the maximum displacement limit, and can be really useful at times. Alright.